Let's look at now this first one. I want you to try yourself. There are some helpful things here, what to use. Give it a go. I'm going to ask you to pause it in a moment and give this a bash, and you can do your own writing. It says your effort, so you know that there's an issue with it. If it's wrong, it'll be good practice. Okay, pause. So now you're back. I've assumed that you've tried this. Let me go through the solution. Okay. So this is the curve. And what's the question? Find dy dx in terms of t. Find the equation of the tangent line. Now we might do a little bit with the picture here. We'll look at what's happening at t equal to pi. So if we evaluate these at t equal to pi, we get cos of pi plus pi sine of pi. Now, sine of pi is 0 and cos of pi is -1. So all that means that this is -1. And then what about this? This is sine of pi, which is 0 minus pi times cos of pi. And you bang that into the calculator and you will get plus pi. So x equal to -1, y equal to pi. It looks to me, let's see, -1, -2, -3, -4, -5. We're looking at this point here. It's kind of hard. Maybe it is flat. I think it'll be slightly negative or flat. Now I'm going to draw as close to flat as I put a slight curve on it. We'll see. But that's the point we're looking at. And we want to find the equation of the tangent line at that point. Okay. So first thing to do for me actually is write down the equation on a separate sheet. Okay. So we'll find dy dx first. So using this formula, so we're going to need little product rules as well, as we'll talk about. So yeah, I think I'll write this again here. So y is equal to sine of t minus t cos t, and x is equal to cos of t plus t by sine of t. So in terms of differentiating these, you've got sine of t minus, so these can be differentiated separately, but you'll need product rules for these second terms. So this will be uv, this will be uv. Now you can, if you want, go off and find the u dash, the v dash, or whatever, but I tend to do it just in one go, and I think it's possible. Well, maybe we'll do dy dt and dx dt separately and then put it all together. That might be the way to go. So dy dt. Okay, so if you look at y, it's a sum of terms. Sine of t is the first thing, and then it's minus t cos t. Now what I would recommend, you definitely differentiate term by term. So the derivative, of sine of t is cos of t. That's the derivative with respect to t. And what I'm going to do is I'm going to fix the minus, and I'm going to differentiate the t cos t in a bracket. Okay, so looking at the product rule, if you've got a u by a v to differentiate it, it's the first thing, which is t, by the derivative of the second thing. The derivative of cos t is minus sine t. Now that's a little bit ambiguous. Is that t multiplied by minus sine t or t minus sine t? To get rid of any ambiguity, you could use a bracket. So that's the first thing by the derivative of the second, plus the second thing, which is cos of t, by the derivative of the first thing. The derivative of t respect t is 1. Now you could alternatively take u to be minus t. It's just have to be careful there. This is probably the easiest way of doing it. So if I multiply this out, if I'm careful, I have cos t minus cos t, that's gone. So I end up at minus t by minus sine t, and that's minus by minus is plus sine, t by sine of t. That's that. Okay. And then dx dt is equal to. So x is slightly easier because there's no negative. So it's cos t plus t sine t. So the derivative of the sum is sum of the derivatives. So derivative of cos t is minus sine t. And now I need to do another product rule on t sine t. So it'll be the first thing, which is t, by the derivative of the second thing, which is cos of t, plus the second thing, which is sine of t, times the derivative of the first thing, the derivative of t respect to t is 1. So again, you get a sine t minus sine t or something like it. That's 0. So you're left with t cos t. And so what we have is dy dx is dy dt divided by dx dt. dy dt is t sine t. And the other bit is t cos t. Now you could simplify that if you want. It's actually equal to tan of t, but I'm not too worried about that. I'm quite happy with it like that. So you could simplify it if you want. So that's the first question done. Dy dx is t sine t over t cos t, or tan t if you want. And now find the equation of the tangent line to the curve at t equal to pi. Okay, so if you want to get the equation of a line, you're talking y equal to mx plus c, but even kind of before that, y minus y1 is equal to m times x minus x1. I'm sure that's on the next page, and we'll probably find those points again. And don't forget radians. So probably the easiest thing would be to go off and find the slope. So we're interested in the slope t sine t over t cos t, and we're interested, I think it was t equal to pi, was it? Yeah, t equal to pi. So we're going to evaluate this at, that's what this bar means, t equal to pi. So if you do that, you get pi sine pi over pi cos pi. Now, it doesn't really matter what's going on with most of this because sine of pi is equal to 0. Again, you have to be in radians. So the slope is actually 0. And now we just need the x1 and the y1 to put in. Now the x1, because the slope is 0, actually doesn't matter, but we won't worry about that. So x1 is equal to the x coordinate, which is cos t plus t sine t, but evaluated at pi. So it's cos of pi plus pi sine pi. So I said we're not actually going to use this, but anyway, this is equal to minus 1. And then y1, the other point on the curve, put in the t into the sine t. So it's sine of t minus t cos t. So put in pi, pi, pi. And bang that into the calculator, be in radians. Sine of pi is 0 and cos of pi is minus 1. So you have minus pi by minus 1, giving you plus pi. So now we'll use the y minus y1 business. So y minus y1 is equal to the slope, which is 0, times x minus 1. 0 times anything that's on the right hand side is 0. So just have y minus pi equal to 0. So the equation of the tangent line is y equal to pi. So the slope is 0, so it's flat. So the picture that we drew is kind of accurate enough. So we showed in part B that this was y equal to, so if you want to write in the form y to mx plus c, it's 0x plus pi. The slope is 0, it's flat. I haven't drawn it flat, but it is, if I did it properly. Okay, we're going to do one more example. Okay, the unit circle is a circle of radius 1 with center 0, 0. The unit circle has parameterization x is cos theta, y is sine theta, where theta is the angle between the blah, 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 blah. Sketch your unit circle together with x and y axis. That should be okay. Find dy dx if x is cos and y is sine. That sounds easy. Hence or otherwise, find the equation of the tangent at 0, 1. Now there's a hence or otherwise. Is the second derivative positive or negative there? Okay, not too bad. So the first thing is the sketch. So what does it say? Radius of 1, center 0, 0. So you're just drawing a circle with radius 0, 0. Sorry, center 0, 0. Radius 1. So here's your center. This is 1 along the x, 0 along the y. This is 0 along the x, 1 along the y. Not the best drawn circle in the world, but that's that. And this is 0 along the x minus 1 along the y. And this is x and this is y. That's grand. What's the second bit? Find dy dx if x is cos. So this is easy enough. So it's dy dt, well in this case, d theta. Actually, there's something we have to check. We need to go back. I'm a bit worried about something. Aha, so go back here to page 110. I made an absolute donkeys of this. See that dt? It's not the derivative because the role of t is being played by theta. So this should be the theta. This should be the theta. It makes a big difference. Okay, so anyway, we're doing that here. So it's dy d theta over d, and so y was sine of theta. So derivative of sine of theta is cos of theta, and x is cos of theta, and the derivative of that is minus sine of theta. Now you can say that that's minus cos theta over sine theta. There's other simplifications, but ultimately that's done. Right, what's part C? Hence or otherwise find the equation of the tangent to the unit circle at 0, 1. So 0, 1 is up the top. So if you actually wanted, you could just actually write down the answer because it's clearly flat at the top and it cuts at 1. So it's just going to be y equal to 1. No problem at all. Now we will actually show that instead. So you can just write the answer down as above, y is equal to 1. Or else what you notice, you have to kind of get what does 0, 1 refer to. Now you can, and we'll do it. So if you can read this and you say theta is the angle between the points 1, 0, the origin, and the point you're looking at. So 1, 0, the origin, and the point you're actually looking at. So it corresponds to theta is equal to pi over 2, which is 90 degrees. In terms of your conversions, pi is 180 degrees. So you could do it like that. Alternatively, you could have a problem here. So you could say at what theta is the x coordinate 0 and the y coordinate 1. So you're looking at the x coordinate, which is cos of theta, equal to 0, and the y coordinate, which is sine of theta, is equal to 1. Now solving these little trigonometric equations it can be a little kind of messier because in fact there's loads of solutions here, because if the angle goes around 2 pi, which is 360 degrees, you start getting more solutions. But really we just need one solution, because like at 0, 1 it doesn't matter what theta is essentially, if it's pi over 2 or I think the next one is 5 pi over 2, the slope of the tangent is the same. So basically what I'm getting at is what you should do is you should solve one of these. So what you could do is solve the top one by doing cos inverse of both sides. So you get theta is equal to cos inverse of 0, and if you have your calculator you'll get pi over 2, and then check your answer in the other one. So sine of pi over 2 into the calculator is equal to 1. That works. So therefore theta equal to pi over 2 corresponds. So I'm saying, what am I saying here? I'm saying find the equation of the tangent to the unit circle at 0, 1. You have the slope in terms of theta, but what is the theta? And if you can't read the question and figure out that it's pi over 2, you have to do this thing that we did on the right. Well, anyway, the theta is pi over 2, and so the slope of the tangent is dy dx. Corresponds to theta is equal to pi over 2. So we're going to put pi over 2 into the dy dx. So that'll be cos of pi over 2 divided by minus sine of pi over 2. And cos of pi over 2 is 0. So it's 0 divided by minus 1, which is 0. So we have a point, which is 0, 1, and a slope, which is 0. So we do y minus y1 is equal to m times x minus x1. The y1 is, the point we have is 1. The slope is 0. And then we have x minus x1. The x1 is 0. But it didn't matter what it is because we're multiplying by 0 anyway. So we have y minus 1 is equal to 0. And I recommend you write your lines in the form y equal to mx plus c. In other words, y equal to get y is equal to 1. If you want, you could say 0x plus 1. In any case, oh yeah, our picture's up the top. You could have actually done it in one line if you kind of understood what you're going on. last bit, is the second derivative positive or negative there? Well, look at that point. The graph is n-shaped there. So if the graph is n-shaped, the second derivative is negative. So the second derivative is negative as it's an n-shape. Okay, so that's the first part of this done.